Welcome back to part 2 of adding and subtracting rational numbers, chapter 3, section 7. This time we're going to start off by looking at a problem where we have a fraction, negative 2/5, and a decimal, positive 2.3, that we're adding together. We say adding together even though we're going to be subtracting in the end because there's a plus sign between them. Now we have to convert them to a common type of number. That means I either need to convert 2/5 to a decimal, or I need to convert 2 3/10 to a fraction that has a common base as the one we have here. And for this one, I'm thinking that it's going to be easier to convert to a decimal, but let's see what they say. Method 1, write both addends as decimals. Hey, what'd I tell you? Because the addends are written in different forms, you can write the first of them in the same form. And let's go ahead and highlight that because that's something you need to put in your notes. That's explaining what we're doing. The decimal form of negative 2/5 is going to be a terminating decimal. So you can either write the addends as fractions or decimals. Yep, pretty much all I just said there. Now let's go through the slides here. The negative 2/5, that's the same thing as saying negative 0.4. And now we have signs are different. Find the difference. So we're going to subtract the 0.4 and the 2.3 from each other. And when we do, let's see, the difference between that is going to be 1.9. But wait a minute. Is it going to be positive or is it going to be negative? The sign in front of your larger number goes in front of your answer. That's larger. It's going to be a positive 1.9. My answer checks. So the sum of negative 2/5 plus 2.3 is going to be a positive 1.9. Now they said method 1, so I think they want us to look at another method to solve it. Let's do that. Now let's go ahead and highlight this because you need to write that down and explain what you're doing here. Method 2, write both addends as fractions. And now we're going to watch a video to see exactly how they say we should go about doing that. Let me zoom out just a little bit, make it fit the screen better, and go.
To add rational numbers in different forms, begin by writing the numbers in the same form. One way to add a fraction and a decimal is to write the decimal as a fraction. When writing a decimal as a fraction, use the place value of the final digit as the denominator of the fraction. If the fractions have different denominators, rewrite one or both fractions using a common denominator. To rewrite a fraction, multiply its numerator and denominator by the same number. Next, add the fractions. Move any negative signs to the numerators of the fractions. Then, add the numerators and write the result over the common denominator. Finally, simplify the sum and rewrite as a mixed number.
Well, that looks pretty simple. Let's see what they have for us to do next. Looks like they're not going to make us work it, but they did give us a talk about it. It said in method 1 you wrote both addends as decimals before adding. Give an example when method 1 is not the best method to use and explain your reasoning. How about when you have a repeating decimal value or a non-terminating decimal value? Then you really want to work them as fractions because fractions are more precise, and I'm going to tell you all year long, fractions are your friends. All right, I'm thinking it's your turn now, so when this problem comes up, you stop the video, you solve this one on your own. You can write them both as fractions, you can write them both as decimals, whatever works best for you. Go. I will give you a hint. You got to do this one as a fraction. Did you do it? Did you figure out why you have to work them both as a fraction? The answer is because of this right here. Divided by 7. Does 7 factor out to be just 2's and 5's? No, it doesn't. And because 7 does not factor out to be just 2's and 5's, that means it's going to be a non-terminating decimal. Okay, so we need to take and convert the 8 3/10 into a fraction. Let me get my slate open here again. So I'm going to do this as 1/7 plus 8 3/10. Now I'm going to change them to improper fractions. 1/7 plus 10 times 8 is 80 plus 3 is 83/10. Now we're going to need to find our least common denominator, and that is going to be 70 for this one. 70 is the first place the two numbers are going to come together. 7 times 10 is 7. 1 times 10 is 10. 10 times 7 is 70. So 83 times 7, that's a little bit harder. Let's see, 7 times 8 is going to be 560. Plus 27 is going to be 500. I'm sorry, plus 21 is going to be 581. I do believe. Let me see if my math in my head was correct. Hold on. 83 times 7 equals, hey, I'm good. What can I say? Now we're going to take and add those two numbers together. That is, of course, going to end up giving us 591/70, which we're going to have to simplify. 70 is going to go into that. Well, let's see. If we were to take and do what I've taught you before and scratch out the last digit on each one, 7 goes into 59 8 times. So I think 8 is going to be the point we're going to be looking at. So it's going to be 8, and then we're going to get a remainder. Hold on. If I did my calculations right, it's going to be 8 31/70 for our final answer. That's a pretty freaky number, so I'm kind of wondering if I didn't screw up. Let's find out. 8 and fraction bar 31/70, accept and check it. Freaky number and all, we got the right answer. Look at this pretty. When adding 3 or more rational numbers, you can use a commutative property to group numbers by signs and forms. Grouping by numbers by the same forms can help simplify the expression. So for example, you've got two numbers here that are decimals. You've got two numbers here that are fractions and mixed numbers. So we can take and use our commutative property and rearrange them. The green numbers are decimals. The orange numbers are the fractions, and when you rearrange them, it's going to end up looking just like that. Now, it doesn't look like they're actually going to solve this problem, at least why it's not on this resource. We'll see what they give us on the next one. The lowest recorded elevation of the contiguous, funky word, United States is 282 feet below sea level, and is located in Death Valley, which I think is in California. Suppose you begin to hike in a parking area near Badwater Basin, which is at 266 feet below sea level. The stopping points for the hike and the elevation traveled are shown on the table. So you've got stop 1, stop 2, stop 3, and stop 4. And it says, what is the elevation at your final stopping point? And now you can see that these are all elevation changes. 1, 2 of them are done as a decimal. 1, 2 of them are done as a fraction. And that led us to this really ugly looking problem, where you started off at the negative 266 feet. From there, you added a negative 12.5 feet. That's here, right here, meaning you went down. And then you added a positive 26 3/5 feet right here. You went up. And then you added a negative 3 1/2 feet right here. You went down. And finally, you added a positive 397.3 feet, which means you are out of the depths of Death Valley. You're going to be above sea level for the final answer. Now, they told us before, we can regroup these things and these problems into a pattern that that makes sense. We can put all of our decimals together, and we can put all of our fractions together. But be careful doing this. You need to make sure you move the proper signs with the proper numbers. So, first thing they did is they took and, actually this one, they didn't regroup squat. They wrote everything as a decimal. They converted the 26 3/5 into 26.6. They converted the negative 3 1/2 into negative 3.5, and that's going to make the whole thing a whole lot easier. From there, they regrouped. They put their negative numbers here together. So they had a negative and a negative. So they're going to subtract these two, and then they put all their additives, positive numbers at the end. So you got three negatives, negative, negative, and negative. Because remember, make the ugly problem pretty by multiplying signs. Positive times a negative is a negative. So these numbers will add together to be negative. These two numbers will add together to be positive. Right about now, I'm just laughing in my heart because the textbook said this entire lesson was a 45-minute lesson. We are way deep into this thing, and we're only barely halfway through the resources they've given us. But we shall push on. Now, what they did is they took these three numbers, the negative numbers, grouped them together, and the two positive numbers and group them together. This is a commutative, the associative property. When they rearranged them, that was a commutative property. From there, the negative numbers, they added all up and put a negative sign in front. 266 plus 12.5 plus 3.5 was 282, and they're all negative, so it became a negative. Signs were the same, found the sum, and then these two numbers they added together as well, getting 423.9. Now they're at the point, signs are different, find the difference, and the difference of these two is going to be, let me see if I can do that one in my head. No, I hate it when they start putting decimals together. So we're going to just grab a real quick pocket Satan here, and we're going to note that we're finding the difference. So 423.9 minus 282, and that's going to give us 141.9. The sign in front of a larger number goes in front of your answer, so our answer is going to be positive, and it checks. From there, the elevation change is going to be an increase of a positive, or they're going to end them up at a positive 141.9 feet above sea level. All right, folks, it's going to be your turn again. You're going to be working this summer camp problem here. Let's see if I can help it to load. Pause the video, work through it, and let's see if you can get the right answer. And almost there. There you go. There's all your information you need. So did you work this totally brutal problem? Let's see how I'm going to end up doing it. First thing I'm going to do, sorry about that thump on the microphone, is I'm going to take and convert everything to a decimal. Because you've got, while there are some fractions in here, they all have different denominators, and I could round them to get the same common denominator and could work with that, but then having a 0.9 and a 0.5 over here, nope, I'm sorry, 0.42 over here, it just wouldn't work working them as fractions. So let's take and change them all to decimals. So I'm going to have 173.9 minus 32, and 3 divided by 8 I think is going to be 3.25, but let's make sure I'm right here. 3 divided by 8 equals 3.75. That can be 0.375, my bad, minus 52.42 plus, that'll become 85.5, and then minus 29.3 and 24. 3 divided by 24, that's going to equal to 1.25. So from there we have everything we need to start working the problem, but I think it'd be a good idea to do what they did before and group the negatives and the positives. So my positive numbers are going to be 173.9, and we'll just go ahead and put a bracket around here, plus 85.5, and then plus, and inside here I'm going to have a negative 32.375 minus a 52.42 minus a 29.125. Now I can come off to the side and do some grunt work. I've got 173.9, 85.5. I'm going to add those two numbers up. That's going to give me a 4, carry the 1, a 9. That's going to give me a 15, carry the 1, and a 2, and the decimal comes down. So right here I'm doing with a positive 259.4. Now I'm going to compile this part of the video and come back and solve it. Next, we're going to work on this part of the problem here. So let me take and draw a line here and just kind of separate out all my junk work here. So I've got a negative 32.375 minus 52.42. I'm going to annex in a 0, and then minus 29.125. What do you notice about all these signs? All the signs are the same, so we can find the sum. 5 plus 5 is 10, carry the 1, that's going to give me 12, carry the 1, that's 8, 9, there's your decimal straight down. This one's going to become a 13, carry the 1, that's going to become a 10, 11, so I'm going to get plus a negative 113.920, or just 92. From here, make the ugly problem pretty by multiplying the signs. So I get 259.4 minus 113.92. We can do that over here. 259.40 minus 113.92. And when we subtract, do a little bit of borrowing here. 10 minus 2 is 8. Borrow again. 13 minus 9 is 4. 8 minus 3 is 5. That's going to become a 4, and that's going to become a 1. So our final answer should be a positive 145.48. Let's plug it in and see if I got it right. 140, whoop. Let's try that again. Oh, wait a minute. They have a fraction. I wonder if it'll work like this. 145.48. They're not going to allow me to do it. 145.48, except, check your answer, they're not going to allow it. But if they do it as a fraction, 13 over 13 fifteenths, let's divide that out. 13 divided by 25, actually, 0.52. I did make a little math boo-boo in there someplace, but you get the gist of how all this is supposed to work. I think this is a really good place to stop part 2. We're about 17 minutes into this video, and I think that's plenty long enough. Come back and watch part 3, and hopefully we can get it all done in one more video.